Hi everybody, today we're going to cover our last lesson of the school year. Chapter 9.4, Testing a Claim about a Difference Between Two Means. So yesterday we talked about creating a confidence interval about a difference between two means, and as you've kind of noticed, now we're looking at testing a claim. So what we're going to do today is state hypotheses, check conditions, calculate the standardized test statistic, and find the p-value. Same things that we normally do, the whole SPDC process. All right, so let's check the conditions first. We've got that random condition that you all know about. And then, of course, the normal and large sample condition. You're going to notice these are the same conditions that we talked about yesterday. Remember that magic number is 30 or more. If you get that, you don't have to look at the sample graphs of each of your independent groups. All right, so these are two conditions. So again, nothing different. We're going to move on here. Let me go ahead and talk about this part right here. So what we're going to do today is called the two-sample t-test for the difference between two means. Now, the test statistic is not a z test statistic, it's a t-test statistic, and as we've said, it's basically like a t-score. What we're going to do, though, is we're going to rely totally on technology, so all I really need you to do right now is know how to use Staplet or your calculator if you still have it, okay? This is the work that goes behind it. Feel free to try it if you want, but again, we're focusing on technology right now. If you want to use technology on your TI, use the two-sample t-test. And depending on whether or not you have a list, you're going to click data or you're going to click stats, depending on, if you get the summary statistics as we call them. And because this is a t-test, you'll see what is my null hypothesis. You're going to have some options, and then you're going to always say no to get your pooled, no for your pooled option always. All right. Now, let's go ahead and look at this problem. Now, if you're going to do it on Staplet, let me just go ahead and talk about that quickly. For Staplet, we are going to look at the two-sample t-test for means right over here. That's the one that you'll click. So I'll show you how to do it in just a bit. Let's go ahead and look at this problem here and finish this up. So, oops, sorry about that. All right, so our problem is, has the mean number of hours Americans work in a week changed? One of the questions on the GSS asked respondents how many hours they worked each week. Responses from random samples of employed Americans were recorded for 1975 and 2014. So we're just comparing one year to the other. And these were sampled independently. You don't want people who were surveyed in 1975 to be in your 2014 group. They've got to be totally different, independent, random samples of employed Americans. And as long as you cover that condition, you're fine. And as you notice, the sample sizes are over 30. They don't have to be the same necessarily. As long as you go over that 30 mark, you are okay. So we've got our summary stats here. And the question is, do these data give convincing evidence that the alpha equals 0.05 significance level of a difference in the true mean number of work hours per week for Americans in 1975 and 2014. So all they're asking for is a difference. They are not asking whether or not one is greater than the other. It's just, is there a difference? Now we can see a difference. It looks like we're working more on average in 2014 as we do in 1975. But the question is that a statistically significant difference? Is that something that has some statistical significance there? And that's what we're going to find out. All right, so now, sorry about that. My pen is acting up here. Now we're going to look at the whole SPDC process here. So state we want to perform a test at the alpha equals 0.05 significance level of this null hypothesis and this alternative. You can start off with whatever group you want first, as long as you get your alternative hypothesis correct. Okay, we'll talk more about that on the next problem. So mu 2014 is the true mean hours worked per week for the population of all working Americans in 2014. And mu 1975 is the true mean hours worked per week for the population of all working Americans in 1975. Two sample t-test for mu1 minus mu2. We talked about the conditions being satisfied already, so you just want to state them just like this. All right, now we're going to get to our do step. All right, so on your TI, you would use the two sample t-test. So this is all you have to write down. You write down the test statistic, the p-value, the degrees of freedom. That's all you need to do is write down what test you're using. Okay, if you are using Statplit, this is how you're going to proceed with this. So again, the two sample t-test for means. And what you're going to do is type in your two group names, type in all the summary stats. Right here, the input was mean and standard deviation. If you input the raw data, that would be if you had the actual data. Here we don't. We just have our summary stats. Click Begin Analysis, and then your inference procedure is a two sample t-test. Yesterday was an interval, today it's a test. No to the conservative degrees of freedom. The alternative hypothesis is a two-tailed, two-sided, not equal to test here. Perform inference, and what you'll see is a test statistic of negative 4.881 and a p-value of 0.001. There go the degrees of freedom. Now, you'll notice here, I had a positive test statistic. Now, that's because I put 1975 first. Or, I'm sorry, I put 2014 first. So if I would have flipped these groups around here on Statplit, if I would have had group 2 go before group 1, I would have gotten the positive test statistic. In a two-sided test, that's not going to make much of a difference at all. It's not going to make any difference because you're going to still get the same p-value here, same degrees of freedom, 1660.58. And our conclusion is because the p-value of 0.000001 is less than alpha equals 0.05, we reject the null hypothesis. We do have convincing evidence of a difference in the true mean number of hours worked per week for the population of all working Americans in 1975 and 2014. All right, so let's read through this problem, and if you want to try it out on your own, just pause the video once we get to the very end. If you want to see the whole solution, just keep watching. So, some students in a very large school district wondered if students who take statistics in high school have greater IQ scores on average than students who don't take statistics. To investigate, they took a random sample of 10 statistics high school students in the district and a separate random sample of 10 non-statistics high school students in the district, and each of the students take an IQ test. So here are the results of our two groups. Now the question is, do the data provide convincing evidence that high school students in this district who take statistics have a greater mean IQ score than high school students in this district who don't take stats? So this question is different in a couple ways. We have a clear direction that we want to test. It's definitely one-sided and one-tailed, and we have raw data instead of summary stats. All right, so if you want to try it out on your own, please pause the video at this point. If not, just keep watching and we'll talk about the whole process here. All right, so let's go ahead and state. So I have mu s minus mu n equals 0. Of course, as I've said, you can say mu s equals mu n. The alternative is we think these stat students have higher IQ scores than non-stat students. Now keep in mind, if for some reason you have the n non-stat students group go first, that would mean your alternative could actually be written like this. You think the non-stat students have a lower mean IQ score than stat students. This would be perfectly fine if you, for some reason, have mu of n go first. Okay, so these are your two alternatives here. Or this would be your null and this could be your alternative as well. So a lot of different ways to start that off. Alright, and mu s is the true mean IQ score for all high school students in this district who take stats. And mu n is the true mean IQ score for all high school students in this district who don't take stats. Notice there wasn't a significance level, so we're going to use alpha equals 0.05. That's a very safe alpha level to use if none is given. All right. Now, we have to state the test we're going to use, which is the two-sample t-test for mu1 minus mu2. We hit that random condition because we have independent random samples of 10 students in the district who take stats and 10 that don't. And now, we also had raw data, and another thing that was different is we had way less than 30. So we have to look at the sample data. And when you go on Statplet and type this in, which I will show you in just a moment, you're going to notice nothing unusual about the graphs. There are no outliers, nor is there any strong skewness. So we pass both of these conditions here, and we're ready to move on. All right, so if you're doing this on your calculator or by hand, if you want to, you'll notice that you get a test statistic of 3.59 and a p-value of 0.001. Degrees of freedom will be 17.83. These are the three things you want to state. You want to state your test statistic, your p-value, and your DF. Okay? Now, if you don't have your calculator with you anymore, your next step would be to go to Statplet and type all this data in. So here, I have my stat students versus non-stat students, and we want to run a two-sample t-test for the alternative hypothesis of mu1 minus mu2. Now, because I have the stat students first, I definitely want to go with the greater than alternative. And performing inference, you'll see the test statistic of 3.587, the p-value of 0.0081, and the degrees of freedom of 17.83, which all match what we have here. All right, now we're ready to conclude. So, lastly, because we have such a low p-value, 0.001, and it's less than alpha equals 0.05, we're going to reject the null hypothesis. There is convincing evidence that high school students in this district who take stats have a greater mean IQ score than high school students in this district who don't take stats. You already knew that. We already know stat students are much smarter than non-stat students, but this is a way you actually go and give statistical proof and provide statistically significant evidence. All right, that's going to do it. That's our final lesson. We're going to have an optional test on Friday. Let me know if you guys have any questions. Take care.